Hi, my name is Noah Gift, and I'm going to talk about how to rapidly prototype computer vision solutions and use this approach to get something working quicker. A lot of times, what I see in the real world with computer vision or in student projects is that there's an embrace of complexity, and then the more you embrace complexity, the lower the chances you'll deliver something successfully. So, what I'm going to cover in this a lesson is how to rapidly go through, build a computer vision model, do some image classification, take it out, prototype it, and then how to use it from different approaches using, for example, Apple's CreateML to using Google's AutoML solution, and how to think conceptually about how to kind of go from 0 to 1 and build the quickest possible prototype in the shortest amount of time so that you can focus on constantly making it better. So this idea of prototyping for success. If you think about a computer vision minimum viable product, one of the ways to think about it is maybe in your first week even, you could go through and use some kind of high-level AutoML tool or a framework or anything to just get something working. Just really quickly get it working, get it prototyping. And then maybe in the second week, you could actually take the output of that and either with a web backend or a mobile device, Google, Apple, SageMaker, whatever, get it deployed, and then actually get that prototype actually in your hands and have it doing some work. Just between those two things, you should be able to then in, let's say, week 3, have something completed and then improve what it is you're doing. Maybe improve the complexity of the model or improve the outcome, maybe like the end result of what it is you're building. But I think it's very important to quickly build something that works, demo it, and then keep making progress. And I'll show you similar to this if we go to Google Sheets. I can show you something I was just working on as well. Like, I think this is a very important concept to consider, which is that you have a project plan that you created that again kind of does those same things. So maybe week 1 you do AutoML classification, and you just do a couple classes, or you do a pose detection, or you do something where you specifically have an end result. And then if you think about it, if you limit the complexity of your project, then your probability of success is 100%, right? The more you can limit how complex the thing is you're working on, the higher the chance that you'll be successful. Likewise, with AutoML, maybe in week 2, you could say, look, I'm just going to get this onto a mobile device, or I'm just going to get this into an endpoint, or I'm just going to get it into JavaScript. And then your probability is very high that you'll be able to finish it. And then maybe in your final presentation, you make it a little bit more complex. Before you were training 2 things, maybe you're training 3 or 4 or 5 or 10. But really, I think the key takeaway here is that each week you deliver something that's working. You intentionally get it smaller than even where you would want to be, and you wait to add complexity towards the end. And so this is how minimum viable products work. So I've built dozens and dozens of real projects that, mobile apps or games or that built millions of dollars in revenue. And the way that we were able to do that over and over again at multiple different companies was that you have something that always works, you make progress weekly, and you make it easy to measure your progress. So that's really the formula that I would recommend for computer vision. Now let's suppose the opposite approach, which I've seen at many companies, especially unsuccessful companies or unsuccessful teams, is that at the very beginning they find the most complex problem that they can work on. They have lots of different ideas, but they never show any progress. That's the doomsday scenario. And then maybe in the week 2, they start trying to get the project to work, and then the probability of success or even being able to deliver something is probably very low. Like the first week, if you just start with, I'm going to build the most complex thing possible. The odds are you won't deliver anything, right? And then if you start to try to work on it, it's very low that you'll be able to even produce some kind of a demo. And then let's say the third week, if you start to try to build something, what you may realize is actually the first thing you were working on was too complex and it never would have worked. And so now you have to scramble and then maybe even go back to like what you could have done in the first week, which is just get something to work. And then maybe you have a much lower chance of success, maybe only 50%. So, and if you look at a typical problem in a company or a student project, here's some of the things that are red flags. One is that if you can't deliver results each week, then that's a problem. There's something wrong. If you don't know if anything works, that's a problem. You need to have something very simple that works. And then also it's very likely that your project will never work if you can't get it working in the first couple of weeks. And then again, if you can't measure what the progress is, then you're going to have, really big problems. So really my advice would be to intentionally make things simpler than you like at first and get something working immediately. So let me just show you an example of this is that let's say you want to initially limit the scope of a problem. Well, what we could do is I'm going to open up AutoML to just start with this, and let's just open this tool up. We can immediately get something working. So we can go here and we can say, okay, let's make a new document and let's do, for example, image classification or object detection or style transfer. Like any of these are computer vision problems. Let's just take image classification and we'll call this, Kaggle, cat, dog. And we can actually go through and find a Kaggle data set. So we don't even need to do the work. So we go through here and we'll put this on our desktop. And then now what's nice about this is that you can see we can immediately start to build something without writing any code, doing anything complicated. So what we need to do here is find a data set that we can just drop onto this. So how do we do this? Well, let's go back to Kaggle and let's find one real quick. So let's go to Kaggle, and if you click on data sets, you can actually even do this computer vision. You could go through and look for classification. You can find different things here. We're going to find maybe dogs and cats. Here we go, dogs and cats, right? And if we go to this particular data set, you can see that we can just download it just like this. There we go, download it. So this to me is a much better approach, which is instead of taking a week to find some data set and collect it yourself, just go for speed. Just get something working, get it immediately. And then once we go here, if we look at this data set, you'll see that in fact, here's the data set. It says dog and cat. There we go, test data, training set data. They have two directories set up, and there's, I think, thousands and thousands of images inside of here. So why not just let them do the work for us, and we can focus on just getting something working, right? Because really our goal is not complexity. Our goal is to eliminate complexity and go for speed, right? And so that's really a methodology to begin with. So let's go for speed. Let's see here. It says training set. It's already there for us. I just drop it right there. There we go. And now if we drop this onto there, it automatically detects it. We've got that working. And then we can also go to test set, and we can put this test data here, drop it right there. There we go. And then it's ready to go. That's it. So I can just click this train button. And basically it took me all of not even 10 minutes to just go somewhere, find a data set, download it, take it, prototype it. And this will take a little bit of time to ingest all of these images in here. But what's great about this is that I can now focus on the prototype part of the problem and solving the problem versus focusing on how complex it is. And again, this is really a really important aspect of building prototypes, is that you are really prioritizing the speed versus prioritizing the complexity, and because they're actually initially in conflict. And if we go back to one of these real quick, let me just open up another project, and let's just talk about this from like a prioritization standpoint. That, yeah, I guess you could almost say that you have complexity. So we'll just say complexity here, and then you have speed, and there really is not a trade-off. That you have to pick where you want to be when you're building an MVP or a minimum viable product for computer vision. And so if you start here, then you're basically making things take a lot longer, because the complexity of your project is going to immediately slow things down. But if you instead start here, so the complexity will be much lower. So for example, if it's like dog and a cat, right? You keep something really simple, that at least you're going to have something that works, and it's easy to make things more complex. That's actually the default for most people, is to start with the most complex thing possible. So instead of dog and cat, you're collecting all the data yourself. You have, you also have maybe 1,000 different labels that you're going to classify. This, you can always do that, right? There's nothing preventing you from making something very complex. But most people start here because it's fun to make things complex. But instead, I would start for the speed, and I would go for just get something working, get it working, because once you get the whole system working and you understand how that process is created, then you're getting a feedback loop, and this feedback loop is really important because it allows you to make weekly progress. And if you start where you're doing the complex part, you're basically broken. Basically, like you have a broken feedback loop, and you can't iterate and try to make things more complex or more sophisticated. So really, this is a requirement, in my opinion, when you're building any kind of a software project, computer vision project, mobile application, is that you need to get something working, even if it's intentionally simple, so that you have the actual device, or you have the endpoint, or you have something working, and then on a weekly basis, you just keep improving it. Every week you make it a little bit better. Eventually, you could get to the point where you do 1,000 labels and you try something else, but first get the simplest thing working. And this is really the essence of how to be successful in an organization. That's been my experience in the Bay Area, Silicon Valley. I've had a reasonably successful career with building products, and part of that was every time I worked on a project that had a problem or was delayed, I would remove the complexity and I would go for speed. And once you get the speed of the feedback loop, then you can build incredibly sophisticated things. But if you start here, you can't go for speed, right? The only way you can get to complexity really is to start with speed. Then you can go to complexity. If you start with complexity, it's very likely you'll stop, and then you can't go forward, unfortunately. So we'll let this thing finish. This will take just a second. A couple things to be aware of as well with this whole process is that you can look at your activity monitor at the same time. I think that's a good thing to be aware of depending on what kind of machine that you're using. But one thing that you'll notice here is that in terms of CPU percentage, that it's actually using a service called for Apple create ML called ML Recipe Execution Service. And this is what's actually going through and preparing the data. So it's basically doing like labeling and data cleaning and all kinds of whatever it is that the create ML tool does to prepare things for doing computer vision. The power of your machine is really the bottleneck for how quickly this is working. This particular machine that I'm on right now is the Apple M1, which is a very, very powerful machine. But I also have another machine that's a Mac Pro that has like 300 gigs of RAM and two GPUs that are very powerful, plus 16 cores. And so that would probably be much faster. So it really depends on, which machine you're on and how much resources you have when you're doing this training. And this is the difference between what I'll show you after this is I'm going to walk through how to do the Google Cloud platform. But in general, when you're doing local prototyping, the speed of your machine does matter. So, again, depending on what kind of environment you're working in and what kind of problem you're solving, it may make sense to have a local machine, like a workstation that's very powerful. So there's really two main decision trees, I guess, is that if you know for a fact that you're going to be using mobile technology, then there's something to like about locally working with a Mac because of how quickly you can prototype and the fact that the Xcode environment is really encouraging you to use high-level tools so that you can focus on building a mobile application. On the flip side, if you don't have access to Apple technology, for example, you have a Windows or Linux laptop or something like that, another approach that works very well is to just use the cloud, and then you can actually have the cloud do all the processing and heavy lifting. They're both fine approaches. Just it really depends on what kind of problem that you're solving. But when I'm using things locally here, like a Mac, I like to look at the metrics like this and see all the different things that are happening, so I can decide whether I need to move it to a bigger machine or how long things are taking. The other thing to be aware of too is that notice that the GPU here isn't really doing anything in this particular process, that the CPU is the thing that's actually taking all the work. So this is a CPU bound process. Later, when it's doing things with the GPU, it could be using more GPU, right, to do the training. Another thing you can do as well, if you're kind of taking a look at what's happening, is that you can also you open up a terminal here, and you could also run like the top command to see what's happening. And you could see, for example, different things that are happening. You can see, like, here we go, ML recipes is taking a lot of the CPU. That's a default thing to run. Or you could also do htop, which you can install with the brew command, and the htop will show you what's going on as well. But we can see here, there we go, very, very, very quick actually when it's training. It was able to complete that. And I believe if we said GPU, we could have probably, create ML I think was probably doing some stuff with GPU, but we can see here that it has, with the training set, very high precision recall. So basically false positive, false negative. And then in terms of the training set, we can see how the training accuracy was 99%. The validation was very high. And then once we've got this working, then it's pretty easy to try some different images out. I have some that I've already downloaded that I'll just kind of drag over here. So here's a few images that I could play around with. And then it's very easy to prototype this. So I can just go here and just throw this on there. There we go. It was able to classify it. Here's another one, 99% accuracy. Here's another one, dogs, right? Now, if I wanted to as well, I could even try a different training run here, which if I go to this, I I believe I could actually duplicate this right like this, and it will actually kind of already know everything that's happening. And I guess I could even rename it and call this version 2. So we'll say cats and dogs v2. And if I want to experiment with how to do more enhanced training, I can just start to play around with some of these, right? Add some noise to it to maybe make it more robust at recognizing pictures that aren't that good, maybe blur it, crop it, do all these different things here. And then again, I just click this button and you can see that it'll start, train the model, and then go through and produce a separate model. And again, you can kind of watch this. Here's our AutoML tool. It's not doing much. It's doing a little bit, but then the majority of the time here in terms of CPU percentage is this thing, this ML recipes is doing its work. So this might take a lot longer to train the model. But the main takeaway here is that you can really quickly build prototypes, try them out, and even put this into maybe this was first week, and then the second week you then take it and put it into an iOS device. Very, very, very easy to prototype. And I think prototyping is really critical for building things quickly so that you understand the scope of the problem. Now, what I can do next here is I'll just kind of maybe minimize this. Let's minimize this because I think the machine is doing a lot of heavy lifting because of how much work I told it to do. But what I can do is actually hide this thing. There we go. We can hide it, and we can work on the next thing that I was going to show you, which is the other thing that we can do is we can also just use Google, right? So if I go to Google console here, they actually have a new system called Vertex AI. And what's nice about Vertex AI is that it allows you to upload a new data set quickly. So here's an example of if I want to create a new data set, we do this. We say, cats, dogs, v2 or something like this. And then it just asks me what I want to do. Image classification, multi-label, single label, object detection, image segmentation. And in this case, this would be what we would want to do, right? We're just picking one label, right? Is it a cat or is it a dog? Go through here, and then I can say create. And then what it'll do is that it will say, how do I want to import the images? Do I want to upload images? Do I want to upload files? Would be if you already have labels, you could actually upload files, or you could actually put it into cloud storage. What's nice though is that I could actually just literally upload a few images myself by selecting files here. And so I think I have this somewhere on my desktop. I put just a smaller section of here we go. Here's just like maybe like 100 different images. So like 100 of the cats and hundreds of dogs. I could just say select all like this and just upload. And then what this will do is it'll just put these into the Google Cloud Platform, and then allow me to do things with it for my model. So there we go. Pretty easy. I just selected this. And then if we go down, I can just tell where I want to put it. So I could either put in an existing bucket or create a new one. I'm going to create a new one real quick. A new bucket. We'll just call this. Let's go back here. Say cats, dogs 2. Cats, dogs v2. There we go. And then I can go ahead and select this. There we go, cats, dogs v2. And then this will upload it into that location. And then once it's uploaded, then it will give me the ability to either do automated labeling, which is potentially an interesting solution. You can tell the labeling service to figure out all the labels, or you can just manually select them, especially if it's a smaller data set, and just click on the buttons and then say whatever the labels are that you want to actually build. And so let's just give this a second. You should see this will take a second to upload this. But basically, it will tell you at the very end, when the actual data set is actually uploaded. So since I've already done this, we don't have to wait for it. I can go here, and I can actually, here we go. You can see they're starting to upload right here. Like I had uploaded one a little bit earlier. Here we go, cats and dogs, and you can see here that. What I did was actually, you can select several like this, and you can just right click, select them and then say assign label. And then basically, if you just go through and add a label, you can then select the label that you want. So in the new one that I just created, which is this one, that once they're actually available, once they pop up here, I could just do a new thing. I could just say cats, or I could say cat, and then I can say dog and add, and then when they finally populate, I can just select and just click on the buttons and then say, okay, add this label. And so it's a pretty straightforward process to rapidly build a prototype here. And again, in this example, not this one, in this example, I had already done that. You can see I didn't label all of them. I just picked like a few of them to label, so that what I could do then was click train new model, right? It's really easy to click train a new model. So I believe if I go to here, models, there we go. I was able to do that. So let me just show you though, how, if we were going to do this ourselves, click train a new model. You could go labeling task, or you could say new model. In this case, I already created the labels, so I don't need to do it. But you could, if you had 8,000 labels, for example, or 8,000 images, it might make more sense to create a labeling task. Since I already did it though, I can just click train new model. Notice that there's 3 different options. One is AutoML, so just basically just do AutoML. The second is AutoML Edge, which will allow you to train it so that you could either export it to Raspberry Pi or Jetson Nano or something like that, or to your phone, or a custom one. You can even go through and actually upload your own computer vision algorithm, maybe TensorFlow or PyTorch or whatever, build containers. I think this is probably the one you would want to select. If you go to next, you would say continue, and then you select, do you want best trade-off, higher accuracy, or faster prediction? I would say maybe best trade-off, and then you select, how many hours you want the model to train for, and then you just go ahead and click training. Since I've already done this, we can go to the model section right here, and notice if I select this, that it shows something intentionally very, very simple, right? Like it shows you a confusion matrix. So it's, it was, again, I only trained it on 12 images because I wanted to go for speed first. It's able to do that. And then if I want to go to deploy and test, then at this point, I have several different places I could deploy. I could deploy it to an endpoint. So if you were going to build a REST-based service, or maybe a website that you wanted to talk to, this would be a good option for you. Or you're building even a backend service only that you communicated with like a command line tool. This would be good. And you could even test this out and preview it. So this is a pretty good feedback loop to be aware of. Another option is that you can also deploy it to TF Lite. And if you click on TF Lite, that this would be an ideal candidate for Android. So the Android phone, there's a good example. There's also Edge TPU TF Lite. So this would be if you were going to use something that use the TensorFlow processing chip, like the Coral device, or another one would be Container, Core ML, or JavaScript. the JavaScript is pretty interesting because you can actually you could prototype your whole project by just having a web browser that does the predictions, or this one, CoreML, right? You can see here the CoreML model. So pretty easy actually to export this. In fact, if I just try this, export your model, and let's put it into, let's do this one, cats and dogs v2. Let's see what happens. Oh, it must be in the same region as your model. Let's try that one. Maybe I need to make a new bucket. So buckets, we'll say models. There we go. Oh, models. CV. Try that. Choose where to store it. I think it says US. If I go back here, I think this is in US Central 1. Okay, so yeah, let's go back to models here. Click on this, go to deploy and test, and select this. And then I could, again, go to exporting it. Now, the other thing you can do as well is you can also just export it like this, which I think is a little bit easier. And I think it'll just download it. And if I go to CoreML, oh no, it makes me do it this way. So let's go ahead and try this. Let's see if we can get this directory set up. So I'm going to create a new one, and we'll just call this store my model 2021. Continue. Go ahead and create. And then let's go ahead and select this, hopefully, store my model, and then export. There we go. So now it's going to take it. We can view the folder. And then now we've got this inside of the storage location. I can just select this, and then I can just say, I believe I can just download this. I should be able to, where is it here? Export. There's a way to basically download this using either like the terminal is a good way to do it actually, is I could just copy it to the terminal. Oh no, here we go, download. That's another way as well, as I could just inside of the, let's try this out. Let's copy it and let's go to activate Cloud Shell, and then I could just copy this into my Cloud Shell terminal, and then from there I could download it. So let's just give this a second. If you don't want to wait, you can use ephemeral Cloud Shell. Sure, let's do that. Let's always use ephemeral. Let's be lazy, just so this thing will open very quickly. Okay, there we go. So if I just paste this in here, in theory, this should copy it locally. There we go. And then I believe that you can actually, from here, download. Yeah, you could download a file. So we could go inside of here and just put whatever the name is of this, like, right? We could just download it. So that would be the feedback loop to bring it down. Now, the other thing I'll be aware that you can be aware of is that this is the older version of the computer vision system, which is right here. And I have an example of a data set like it's similar. The Vertex AI and the AutoML computer vision are basically the same thing, but this is one from a couple years ago. And notice that I can go through here and look at all the labels, and all that's pretty useful. And then if I go to train the model, I trained two kinds of models. I trained a one for the cloud, so this was designed to be trained as an endpoint, and then I trained a second one that was available for the basically downloading this as an edge-based device. And so if I click on this one here and I see full evaluation, I can see all the metrics, confusion, data, so all of the descriptive statistics. And then if I go to test and use, what's useful about this is that I can go through here and just like the other interface, but if I click on this, it even shows me like a link to the documentation. So let me just take this out. I don't know why they broke this documentation, but basically it walks through and shows how you can integrate a AutoML model. So really it's pretty straightforward. You would just take this model that they give you and just drop it inside of here. Of course, you could use CreateML to do the same thing. If you wanted to use, and let's go back, if you wanted to use the Android approach, let's go here. Yeah, if you want to use the Android approach, you could select this one, which is TF Lite, and notice that it shows you the Android Quick Start. And really, you just go down here, use this sample project that they give you, and again, it shows you go Edge device export, install the Android Studio on your application, on your desktop, go through and kind of follow these guides here till finally you get to the point where you're able to get something that looks like this when you have this on your application. And then notice that it's doing detections based on a model that they include, but you just swap out the model, right? You just swap out the model. Now you have a full working prototype. So I do think you could build something like this very, very quickly to start prototyping what it is you're trying to build. And if you have Android, that's one approach. You have iOS, that's another approach. The other one, that if you wanted to use physical hardware, if you select Coral here, you could actually go through here and select the Quick Start, and you could see that basically the USB accelerator is probably the way to go, because I've actually personally used this quite a bit, and I have some videos actually that I uploaded to the O'Reilly platform that show how to go through this as well. But basically, you can just take that model that was trained inside of Google Cloud, dump it onto this device, and then it will start to do predictions. So then you could hook this up to, let's say, a Raspberry Pi, or you could hook it up to some other small-based edge device, even your laptop. You could plug it up to your laptop, and then it's the thing that would be doing the inference or the predictions. And so this is a really good device to use for to prototyping things that run on the TensorFlow processing unit. And really the advantage of this approach here is that they really can point you into all these different directions. JavaScript, you can do it in your browser. AutoML works with iOS. Coral works with the edge-based devices. And in your case, you would just go to, again, the Vertex AI approach, and this would allow you to basically get that feedback loop working very quickly. And it really is nice because you have all of these data sets that are cataloged, and so you can always look at them, add new data sets. You can also look at different models, so you could train lots of different kinds of models over and over again. You could also create batch predictions or online predictions. So you can really prototype everything inside of a dashboard like this, just like with Apple's CreateML tool. And I think this is the way to go for initial prototyping, because again, you're going for speed. You want to get something working, and then later you can always make it more complex. But if you limit the scope so that you get the feedback loop working, it's always easier to make it more and more complex, more robust. But especially as well, if your end result is you want to get it onto, let's say, an iOS device or an Android device or something like that. So this is really my main advice, is that it's important to go for speed when you're prototyping up things from a computer vision pipeline. So let's go for a few questions here. Let's see. So what's up? So CreateML is using CPU instead of GPU. I think CreateML is using CPU for data engineering tasks and for data cleaning, but I believe it does use the GPU for the training tasks when it does get to that. And another question is, when I use CreateML, the extraction process is quite slow. Are there any approaches to speed up the training when we use AutoML? Yeah, I don't know if there is. I think it's still a early phase prototype, and so I think it just takes a while. One of the things you could do initially, though, is that you could limit the amount of files and just first get the prototype working with only like maybe 20 files or something small. Just get it working, get the whole end-to-end system working, and go for speed. And then later, you could go through and make it more and more complex when you're training. I think someone said, what about iOS? So yeah, with Google Cloud, you can deploy to iOS as well. But yeah, in general, the speed approach here is really what's important, in my opinion. And let's go ahead and look. This is the second model that I trained. So this one is got, I think it already trained, right? So that actually didn't improve the model, right? You can see that adding all those different settings to it, even though it made it more complex, like the augmentations, look, it didn't make it as good of a validation accuracy. This is 97.9, and this one was 99.5% validation accuracy. So just because you can add a bunch of changes to what you're doing, it doesn't necessarily mean that it's improving it. And so this example too, you can see even it says model converged at 10 iterations. This one, same thing, model converged at 10 iterations. But either way, the output tab here is where you would then go, and if you wanted to, you can just download it, right? You just click on it, download the model. Now it lives on your desktop. You could also go to Xcode, select this. It would open it up into Xcode, and you can start to build an iOS project. You could even share this, which is kind of cool. You could just send your model to somebody you know. Just send it as a text message. But yeah, again, right here you can prototype it. If I go to preview like this, you can. It basically, once it's in the model format for CoreML, you get this whole interface that lets you play around with the way it prototypes. So we can click this. There we go, right? And then if we look at predictions, you can even see that it'll tell you exactly the parameters of this. So image, color, 299, 299, flexibility, input image to be classified. It'll even tell you what it's gonna the output data type is. It's a dictionary. It even has a description, the probability of each category. It says a string, most likely image category. So it gives you a lot of enhanced features when it's in this ML model format. And then also, if I want to encrypt it, I can do this. And if I want to do model archive, so create a model archive to prepare your model for CoreML deployment using CloudKit. And I believe that this is preparing it. So if we do this, let's go ahead and try this out. It's saved to disk. And if we look at the documentation here, let's go ahead and look at what the documentation. So you can also create a target that makes it easy to make a deployment that sends an iPad specific model to iPad users. And so this deployment here is just part of their kind of process here that allows you to package this thing up and give it to other devices. So it's a pretty sophisticated prototyping tool that I do think is an important one to be aware of, and it really is helpful in terms of just getting the feedback loop, right? Getting the feedback loop. All right, so another question here is, how can we use third-party frameworks on GCP for specific tasks? So yeah, if you want to go back here, let's try that out real quick. Let's go to data sets. So in order to do that, what you would have to do, if we selected this, cats and dogs, we would say train a new model. We would select this, custom training. Let's go to continue. you basically could even go through here and like tweak the data split. You could do all kinds of other things, do debugging. But if we go through here, what you would need to do is either use a pre-built container. So notice that inside of the TensorFlow Vertex AI, inside of Vertex AI, they have pre-built containers for custom training. And so you can see here all the ones that they already got built. So they have, in this case, TensorFlow version 2.5, and they also have one that has GPU support. So they have one that has GPU support. If you're going to train on a GPU, they have another one that does not. They also have older versions of TensorFlow. So they have a lot of TensorFlow containers. And let's see what else containers that they have. They have scikit-learn as well. So you could use scikit-learn here. And then in addition, we have PyTorch. So you could use, with the custom training, you could use TensorFlow with or without GPU. You could also use scikit-learn. You could also use PyTorch. So there's a bunch of different models here that you could use that are custom. The other thing that you could, so that's one option. Or another thing you could do is you could actually build your own container from scratch, which would definitely be an advanced task. And let's say you want to use like a more exotic deep learning framework like Caffe, or maybe use MXNet from AWS, which, although it's open source, you could actually go through here and build a custom container and put it inside of there. But yeah, you would basically go through that, say, let's just go ahead and do as much as we can. We'll just pick TensorFlow 2.6, go through, here's before you begin, you need to package and upload your code. Right here, you package it and upload it inside of here. So there's a lot more steps to building things using the custom architecture, but it is an option that's available. Okay, so next question is, how accurate do we usually train the model to be in CreateML? Is that okay? Yeah, I think, again, for the idea here is that the accuracy initially is less important, in my opinion, than the speed, right? Just get anything working so that you can have a prototype, so you can figure out whether the problem is feasible. That's the most important part. Is the problem feasible? Is it seem like it's like, if what I'm trying to do is I want to figure out whether a cat or a dog is I can determine between the two things. This is the first start, is get it working and put it onto my iOS device. And then I can go and take pictures of cats and dogs and test it out and say, hey, look, it looks like it's working pretty well, but maybe there's certain dogs that it doesn't classify as well. That's an enhancement. And I can always get more data or do different techniques and enhance what I'm building. It's a lot more difficult to go through and have nothing working and try to enhance nothing, right? So this is really the goal with these rapid prototyping, is that you figure out whether the problem is feasible, then you improve the accuracy. Okay, so what does a Docker container do? So with containers, you can think of them as they're basically a way of packaging your code. And so if we go to this right here, there is a book that you can take a look at, Cloud Computing for Data. I'll just throw this in here. And basically, if we go to this section, containers, the idea behind a container is that you can actually package the runtime of your code together with the source code. That's really what a container does. So you can be assured that it will execute on a Linux environment with TensorFlow, for example. And so locally, most people are using something like Docker Desktop to do that. That would be a way to play around with it. If you wanted to experiment with a online version of this. There's a bunch of hubs like Docker Hub. There's GitHub has a container registry. Google has a container registry. But in general, the idea here is that you package the runtime plus you package the source code and even the model, and they all can go together at the same time. TF Lite with SageMaker, I believe you probably could do that. If you wanted to do predictions inside of the SageMaker platform. So SageMaker can do a lot of different things in addition to taking models that were already trained somewhere else and then doing predictions on them. So I believe you can actually do that. And now, I don't know if you would necessarily want to use TF Lite. You may just want to use TensorFlow, because if for sure you can do TensorFlow predictions with SageMaker. TF Lite is more for doing edge-based predictions because it makes the model a little bit smaller. How does AutoML train a model like images? So the way the AutoML system works really is just, in the case of this particular project, right, is that because we've already put the images together in a folder, that it knows that the top level of this is label 1 and this is label 2. So basically, as long as you keep things, they have the same number of images and they're in a directory, it'll automatically figure out what the label is. And from there, it knows that because we told it initially what the problem is we're trying to solve, right? Because if we go back here and we say File, New Project, I can go in here and I can create any kind of project I want that it can do. Like, because I told it to do image classification, it knows that I'm going to give it a directory that has a bunch of images inside of it. But we could also do different kinds of problems. We could say object detection, and it could go through and try to do object detection. In fact, we could try that. Let's go ahead and try that. Let's do object detection here, and we'll just create this on our desktop. And then if I go through here and I put that same, if we put the same just this cats directory, let's try this. Unable to find. So it looks like it needs some annotations in order to do object detection. So that one isn't as simple as doing the classification. The classification knows that you just have a directory, and whatever is inside of this directory are the different labels, and then it takes it and then it does automatically applies a computer vision, a deep learning model to it, and then figures out how to classify between those two different labels. And that's really all it's doing. And then when it's done, it creates the evaluation here that shows you how accurate it was, and then it lets you take the output and then it makes a model at the end. But that's really how it works in a nutshell. So next question is, I noticed that there will be a charge for the training on the Google Cloud Platform. Is that charge going to be high, or how can we minimize it? Yeah, so that's a good question. A couple of things to be aware of is that they do have Google free tier. So by default, if you create a new account with Google, you get $300 in credits. So that's quite a bit of credits to start with. And then that's one place to start. The other one is that Google, let's see, Vertex AI AutoML costs. I think if we look at this, that they do let you do, let's see here. So training would be, you must pay per node deployed, even if no prediction. You must undeploy your model to stop getting paying for it. But basically, to train it itself would be $3 per hour to do a classification. But remember, again, you have $300 of free credit, so you could basically train lots of different models very easily, and still be within the free tier. So how many node hours should we set for the data set? What impact does it have? So it's really non-deterministic in terms of how many training hours you should set. Like you don't know until you try it out. Uh, there's going to be at some point it finds the global minimum, and then at that point you're done. And so you may want to set it higher or lower, but in general, I would say for a student project, you want to keep it pretty low. Maybe just start with 1 hour so that you constrain it. If it was in the real world, I think you would have a little more flexibility where you could tell it to train the model. If we go back here, for example, and we say, here's the data set, and I say train new model, and you go through all the stuff, we'll just say AutoML. Notice that you can do this, enable early stopping. So like I could say 100, right? But it would actually stop it if it can't find any more improvement. So it'll automatically figure out the best estimate to select. Okay, another question is, I want to know if we can transfer a model trained by Python into core ML files. You can, I believe, do that. So there's something called Python Core ML Tools. And with this, I believe you can go back and forth between Core ML format. So yeah, if you wanted to play around with this, look at this library. So if you could just download potentially a model that was already created. I think I covered that actually in the Practical MLOps book. Basically, I took a model that was already pre-trained, and then I just convert it to Core ML, and it works just fine. So yeah, you can do this by using this library. So would it be better to use object detection than classification for our expression recognition project? It could be that there could be multiple approaches you have to apply at the same time to a real-world computer vision project. But I think that if it was me, I would probably take a still frame of an expression and make it image classification problem versus object detection. Next question is, do we have a limit on the size of the final trained model? Is bigger better? I don't know if that's necessarily the case, that a bigger model is potentially better. I think it depends on the problem that you're trying to predict. But for the final trained Core ML model, I don't know if they're that large. I think they're typically under a gigabyte. I haven't seen one be very, very large though. But in general, I mean, you can even look, if you just go to the size of this. If I just go here and I just say git, and we just take this file. Where's this core ML or .ml model? Where's this thing? Yeah, here we go. Here's this. If I just drag this onto my desktop, we can see that if I say get info, that it's this one in particular is very small, because I don't think it's doing a lot of stuff, but it really depends on how many different things that you're trying to classify. If you're trying to classify 1,000 different items, that could potentially be very different than something that is only classifying a cat and a dog, and it's a very small data set.